Welcome to Get Your FRQ On. This question is from 2024. It's question 5, and it is not calculator active. In the question stem, we have a curve given by an implicitly defined function, and we are also given a formula for dy dx for that curve. In part A of this question, we are asked to use the tangent line to the curve at the point 2, 4 to approximate the y value when x is 3. So to do this, we have a formula for dy dx. We're just going to use that formula specifically at the point 2, 4 to get a slope of our tangent line, and then we'll write the equation of that tangent line and use it to approximate the value of y of 3. All right, so dy dx, specifically at the point 2, 4, just plug in 2 in for x, 4 in for y, and we get a slope of -4/19. All right, so writing the equation to the tangent line at this point, y minus 4 equals -4/19 times x minus 2, which means y is equal to -4/19 of x minus 2 plus 4. Then, to approximate the value of the function, when x is equal to 3, we're just going to plug in x equals 3, and we get 4 minus 4/19, which is 72/19. Any one of those last two would be okay. In fact, not going to lie, this would probably be okay as well. So any three of those on the bottom row. Also, if you have it as a mixed number and it's correct, that would be fine too. In part B of the question, we are asked if the horizontal line y equals 1 is tangent to the curve and to provide a reason for our answer. All right, so if y equals 1 and it's tangent to the curve, that must mean that there is a point on the curve where y is equal to 1 and dy dx would have to equal 0 there. Okay, so let's assume that y is in fact equal to 1. If it is, then the rest of the equation indicates that x squared plus 5 would have to equal 48, and so x is either plus or minus the square root of 43. Great. Let's plug in those values into our formula for dy dx and see if we get 0 for any of them. All right, so if we plug in the negative square root of 43 in for x and 1 in for y, we get a slope, but it's not 0. And if we plug in positive square root of 43 in for x and positive 1 in for y, we also get a slope, and it's still not equal to 0. So even though there are 2 points on the curve where y is equal to 1, the slope of the tangent line at either of those points is not 0. And so no, the line y equals 1 is not tangent to the curve, since dy dx is not 0 at either point on the curve where y is equal to 1. In part C of this question, we're given that the curve has an x-intercept at the point square root of 48, 0. And then we are asked if the tangent line to the curve is vertical at this point. Well, if the tangent line is vertical, then it must be undefined. If we actually substitute in square root of 48, 0 into our formula for dy dx, we get a defined slope. -2 square root 48 all over 3, and that is not undefined. So our tangent line at this point is not vertical, and therefore no. Tangent line is not vertical at this point. We get a slope which is not undefined. In part D of this question, we have another implicitly defined function, y cubed plus 2xy equals 24, and we're given that dy dt is equal to -2 at 4, 2, and we are asked to find what is dx dt. All right, well, we're just going to differentiate this implicitly. Y cubed plus 2xy equals 24 implies that 3y squared dy dt plus 2 times the group x dy dt plus y dx dt, notice the application of the product rule there, equals 0. And then we can just manipulate this and solve this eventually to get a formula for dx dt. All right, well, dx dt should equal the opposite of dy dt times 3y squared plus 2x all over 2y. And at this point, I can just substitute the values I know in there. Well, I know dy dt is negative 2. I know I'm at the point 4 comma 2. And if I evaluate dx dt specifically at the point 4 comma 2, I get a value of 10. So at the point 4 comma 2, dx dt is 10. Don't forget to like and subscribe if you find the videos that we make here educational and useful. Thanks for joining us at Get Your FRQ On.